Hello everyone, my name is Anton Pelcher. I'm an engineer and I've been building fish farms for over 10 years. In the next common videos, we're going to talk about such an important topic as fish holding tanks. What kind of tanks are usually installed at RAS farms? Which material are they most commonly produced of? How to properly choose the tank's dimensions in accordance with the type of fish and its weight? And in general, how to understand in all the variety of shapes, sizes, materials that exist. And what is also of great importance, how to properly supply water as well as to discharge it from the tanks. You will see this and much more in 3 videos devoted to tanks and their selection. So be sure to watch all of them, because after learning all that, you will surely be able to understand how to properly choose the tanks for your RAS fish farm. And we'll start with the materials which fish-holding tanks could be produced of. Which material is better, which is worse? How could you choose the right material for a tank in all the abundance of alternatives? Sure, there is really an abundance of materials that are used for manufacturing of fish-holding tanks. These are plastic, polypropylene, polyethylene, fiberglass. These are also polyvinyl chloride or PVC film. Flexible film. I'm pretty sure that you have seen Chinese swimming pools for children made of such PVC film. This could be concrete as well as various metals like stainless steel. What I mean that there is a great many of such materials. Let's now consider the major ones more closely. And we'll start with plastic, that is polypropylene and polyethylene. In fact, there is also PVC, but I will say right away that PVC sheet is not widely used for tanks manufacturing, because it's too brittle, and if the tanks change the shape when being filled with water, very often they just burst. That's why practically no one makes tanks or PVC, exactly due to the fact that it's too rigid. So now let's consider polyethylene and polypropylene in more detail. Let's start with polyethylene. In my country, this option of tanks production is called rotational molding. What is it? Imagine that there is a large machine, and this machine is equipped with a special forming unit, polyethylene granules, and polyethylene is very similar to plastic. Are poured into that molding unit or just matrix. They spread over the form heats up and rotates inside the machine, and the granules melt and spill out, filling the whole matrix. So when this matrix cools down, you open it up and you get the final molded product. What are the pros of this approach in general? Well, you can certainly roll these sheets used for tanks welding by hundreds. Obviously not hundreds per day, but dozens for sure. This technology is easy and cheap, but it has also its drawbacks. What are they? First, in order to make a tank of any shape and size, you need to prefabricate a separate form. In my country, it costs around $6,000, and that's the cost of just one matrix. And of course, this is the maximum transportable size. Your tank is already welded, and you need to transfer it to your farm. And if there are dozens or even hundreds of such tanks, the maximum adequate and transportable tank diameter is 2.40 if it's a round tank. The maximum possible diameter? Well, in case you have an open track, it's 3.5 meters. And if you need to transport a bigger tank in Russia, you won't be able to. I'm pretty convinced that in your country it's more or less the same. Of course, you could try, but the logistics costs will be simply inadequate. This is the second major disadvantage of tanks produced with the method of rotational molding. The second option of plastic tanks is those made of polypropylene. How are they usually produced? I think everyone who is interested in fish farming not the first day knows that very well. There are polypropylene sheets that are rolled at special factories. In other words, it's no longer crumb or granules, like in the case of tanks produced using rotational molding method. Polypropylene sheets are rolled at a factory, and then they are folded compactly. You can send them to any farm and weld these tanks the way you want right on the spot, with the use of an instrument called an extruder. The advantage is that you don't need to spend money on expensive logistics of already welded tanks. You can relocate these tanks to any distance and with minimal cost. The second is that they are very convenient in terms of welding, meaning you can weld any actual shape and size. Yes, there are nuances with the thickness of the sheet and with the outer frame, but nevertheless, you can weld the tanks of almost any shape and size. And the third, they are very durable and easy to use. So I could say that they don't differ much from rotomolded tanks, but frankly, these ones certainly look nicer. Another advantage of polypropylene tanks is that polypropylene is conventionally eternal. it doesn't corrode, it doesn't fall apart into pieces, it doesn't rust, nothing happens to it. That is, if you use the tanks for their intended purpose, as it should be, then it will serve you almost forever. Because plastic practically doesn't enter into reaction with any other chemical elements. But this is where the tricky part comes in. Try to avoid contact of plastic and ultraviolet or ozone, because ozone gradually decomposes polypropylene, and ultraviolet also does the same. Yes, there is a special ultraviolet protected plastic type, but nevertheless, it's better not to allow ultraviolet enter into direct contact with plastic. So be aware of these pitfalls and try to avoid them. These were the main advantages of polypropylene tanks. What disadvantages do they have? Well, actually there are some. If you want to weld them yourself, firstly you will need special instrument, an extruder, and secondly, special knowledge of how to weld these tanks correctly. But not only theoretical knowledge, but practical one, experience. So, be prepared to have certain equipment for welding, or find some contractor who is experienced enough and will do anything on the spot. That's basically all I wanted to say about polypropylene tanks. They're good and reliable. I think they're the best option at 90% of fish farms. Here we go. Next material the tanks can be made of is concrete. I get that formerly, a few decades ago, all fish holding tanks were made of concrete only, before plastic technology appeared or it was not commonly used. And what are reinforced concrete tanks? You make a reinforcing frame, preferably with double reinforcement. Pour it all in concrete with special hydrophobic additives, and basically the tank is ready. Let's look into it. What are the advantages of these tanks? Concrete, of course, is also an option and is very often used for tanks and water treatment reservoirs, so you don't have to be afraid of that. It's a good material, but under certain conditions. The advantages of concrete are, of course, its phenomenal endurance and rigidity. That is, if you make a good reinforced concrete tank, it will withstand any load. It won't need any external reinforcement, no frames, nothing like that. You already have an internal reinforcement frame. The next advantage of concrete tanks is certainly their cost, provided you have your own concrete plant. Of course, if you ordered these tanks on a turnkey basis from someone else, you might find them even more expensive than plastic ones. Well, it all depends on the shape, size of the tanks and other nuances, so it's difficult to compare the cost of concrete tanks and plastic ones directly, because it very much depends on where you do it and what shape and size of the tanks you need. Concrete tanks are made optimally if they're sunk in the ground. That's the first issue. Also, if they need be very large and of irregular shape. Why? Because, for example, a rectangular tank made of concrete perfectly withstands the load, but rectangular tanks made of plastic require an external metal frame. Concrete tanks with the volume of 200, 300, even 500 cubic meters can be easily done, while it's very difficult to make the tanks of the same volume from plastic. Because plastic thickens, requires an external metal frame, and it turns out to be much more expensive than making the same tank from concrete. And the second point is when you make water treatment tanks. Why are they very often made of concrete at industrial farms? When you make a plastic tank sunk in the ground, it will just get crushed by the soil. You will not see it initially, but gradually the soil will press on the walls of the tank and you will get the tank of an irregular shape. So if you bury a plastic tank, it will still need an external concrete frame. So why make it up when you can do it in concrete right away? Let's talk about the disadvantages of concrete tanks. Well, the first one is the extended period of time needed for their setting up in place. How much time is required to weld a plastic tank? Well, from half a day to 1 day, if you have all necessary instruments and some experience. How long does it take to make a concrete tank? I presume that you are well aware it's necessary to bind the frame. You need to provide for a concrete pump to pour the concrete, or mix it manually. All in all, it's a long story. Therefore, making concrete tanks is usually 3-5 times longer than doing the same using plastic. The next point, when making concrete tanks, it's very important to have the right approach in terms of technology. If you just pour any concrete, it often cracks, it needs to be reinforced, it needs special treatment. So in short, if you don't make a concrete tank properly, gradually it will start leaking anyway. The next disadvantage: you can cut any plastic tank in halves, even if it's big, and transport to any other place. Of course, this will not work with concrete, because if you have poured any concrete tank, you will not relocate it anywhere, because the process of dismantling a concrete tank is very expensive and complicated. It's important to understand that if you fill in the tank, it will stay there forever. You will not transport it anywhere else. It's obvious. Another nuance is that the concrete itself is rough, which means that fish hurt itself. And secondly, a recently poured tank can emit all sorts of nastiness into the water. Firstly, we don't know what additives are added to concrete. Secondly, I think that you realize that when you pour concrete, it can raise the pH of the water. Therefore, if you pour a concrete tank, especially if you want to have fish in it, it's advisable to treat it first, before stocking. Or it can be lined with the same plastic. For example, you take thin plastic or polypropylene, around 4 mm thick, and simply line and weld it inside the tank as an inner shell of this tank. Then it becomes strong. Concrete gives strength and durability. Plastic provides for longevity, and concrete doesn't emit any harmful substances into the water. Or you cover the tank with a special liquid membrane. There are such membranes. They are like liquid rubber. You treat the inner surface of the tank and it actually becomes rough, rinses well, is cleaned and doesn't emit any nastiness into the water. But let me reiterate, this is important to consider, that is an additional cost. Therefore, concrete is a good option, but it has lots of nuances and aspects that must necessarily be taken into account. To summarize everything, I've told you about concrete tanks. I would recommend them if: A. If you are burying the tank below zero level. B. You need a tank of a huge size, more than 100 cubic meters, especially if this tank is rectangular, because a rectangular tank made of plastic necessarily requires an external metal frame. A concrete one doesn't require that. Well, the next material is PVC film. What is PVC film? Imagine, you're at a country estate. You've got a pool on your lawn, which is made of a soft film with a small outer frame. Children are bathing in it. And it's a classical suburban story. That's the PVC film swimming pool. Press the like button if you've been swimming in a pool like this too. So now let's consider fish holding tanks made of PVC film. In theory, it looks very interesting. You can put the simplest, cheapest tank, buying it for pennies, put fish in it, connect the water supply and water drainage. Everything is cool, everything works. The fish is in the tanks and you have spent practically nothing on that. Sounds great, but there are nuances. Let's consider these aspects right away. You choose this cheap tank, which you can even buy in any shop. It's made of a thin film, or rather low quality. I mean that even kids can simply tear it up, and fish also tears it easily. And if you hit it by accident with a fish net or something else, it will surely leak. That's why the weakest point of all these tanks is that they are always leaking. There is always so much hassle and so many problems. I've seen a 2-kilogram sturgeon just speeding around such a tank and easily tearing a hole in it. I mean that you can grow fish in these tanks, but they are very unreliable. Also, the connection of these tanks to water supply and drainage, it's also very unreliable. You have to make a bottom drain or some kind of additional drain, and then you start having problems with leak and so on. You might ask, is there a reliable enough option of these PVC tanks? Well, of course there is. They're not on sale ready-made. You can buy PVC film, make a frame yourself and assemble such a tank. But this has been considered multiple times and even tried and implemented. In fact, the price is the same as if you were using polypropylene. Then the question arises, what's the advantage? If it costs the same, it's still relatively unreliable as it can be torn. It's worse in terms of welding the pipes. Why use it then? That's why, in fact, it's rarely used. But it still has its advantages. The pluses are that it's dismountable and relocatable. That is, you can disassemble the tank, unfold it, roll it up, relocate somewhere else. If you have a temporary production facility, you put such tanks which you will then need to transfer to some other site. In this case, it's most likely a very good option. So as stationary tanks, which you will use for many years, I would not consider them because of their low reliable. But as a transportable temporary option, they are worth being considered. Let's continue. Fiberglass. It's an interesting material that is very often used to make various boats, as well as many other structures. Even composite materials are used to make various parts for the planes. Generally, fiberglass is a good and durable option. How is it made? There is a special mesh, which is placed on the mold. And this mesh is treated with a special liquid compound from the outside. That is, in fact, plastic, two-component fiberglass. So there is some frame which a special liquid compound is applied to, which then hardens and you get a single monolithic seamless structure. What's the advantage of fiberglass? It's actually a cool material, which, by the way, is used at many fish farms. I like the fact that it's possible to make tanks, podiums or stands from fiberglass, and this will be a single molded construction, a tank with the bottom drain and the podium. The second thing is that fiberglass is very durable. Compared to polypropylene, which is quite soft and plastic, it's very stiff. It withstands load very well and doesn't need any external metal frame, even in a rectangular one. It's cool, of course. Basically, I can also say that it doesn't emit any impurities and harmful substances into the water. It's durable, it doesn't corrode, it can serve you for ages. That's a plus accordingly. Let's talk about the drawbacks. The essential is that it's more expensive than polypropylene. You might ask why. Honestly, I don't really know, but in my country, it's that way. I personally don't offer fiberglass tanks to our customers, but if you browse the internet in Russia, the fiberglass tanks are on average 30–40% more expensive than polypropylene ones. Why use them if there are cheap alternatives? Let me stress, the cast, wholly molded tanks are a very cool option that you can install right away. The second disadvantage of fiberglass tanks: they have to be prefabricated. You can't make them on your site. So, if you envisage tricky issues with transportation, or you cannot bring ready-made equipment inside the building due to narrow door opening, then fiberglass tanks are not your option. Sure, there are segment tanks. These are a large tank, which is oversized, divided into segments, transported to your site in those segments, and then the segments are connected with special bolts or rubberized, glued, welded, twisted right on the spot. And everything seems to be fine. But it's already a little bit different tank, because it already has seams that can leak, and that could be a problem. So, all in all, I'm convinced that fiberglass tanks are a good option. But as usual, they also have a number of special aspects. And also the last and very important point, they're easy to break. On the one hand, they're very durable, and on the other hand, they're fragile. If you hit such a tank, the plastic will absorb the impact. The fiberglass, given that it's brittle, will simply break, and you'll have to patch this hole, repair it somehow. And this is not the most convenient option. That's why fiberglass tanks are commonly used, but I would not name them the best option. But I would certainly use them in some special, standalone cases, for example, level trays, and other technologies. These are metal, stainless steel, and some other options. Basically, if any of you know more good alternatives materials for fish holding tanks production, be sure to write in the comments. I'd love to read it and discuss the options with you. But in fact, if you consider what's offered on the market now, you will probably find no other alternatives. As always, I need to mention that I am referring to my country and the CIS countries. Stainless is very expensive. Ferrous metal will become unfit for use after a few years, as microclimate in RAS is very corrosive. Carbon dioxide is constantly present in RAS, and if there is also ozone, then metal will get covered with rust very quickly. So the rest of the materials are either too expensive or not very user-friendly. Therefore, I will not focus on them. I have outlined the most basic and the most commonly used types of tanks for RAS fish farming. But still there are lots of various materials. How do you choose the best one for your fish farm? Well, I'll be honest, I prefer polypropylene. Why? Probably because it's the most convenient in the combination of all its characteristics. And I am not the only one who advocates for this material, because now probably 70–80% of all RAS fish farms are using polypropylene tanks. So I decided to prepare a little bonus for you. Following the link to this video, you can download the file in which you can pick up the right polypropylene tank wall thickness. so that you can generally calculate the cost of this tank. Download this file from the link in the description and select the right thickness of plastic for your polypropylene tank. Friends, when I was preparing for shooting this video, I presumed I would fit into one video time limits. But surely there is so much to be said about the tanks that we can't fit into one video format. So there will be second and the third parts also devoted to fish holding tanks used at RAS farms, in which I will tell you about other tanks' characteristics, such as shape, size, water supply, drainage, and fish catching. So be sure to watch the other parts as well, and you will learn a lot of new interesting things. This is Anton Pelcher. Press the like button, subscribe to my channel, the channel on how to grow fish and make good money from it.